Welcome back, everybody. We are here in a new episode for the course Collaboration and Unity Basics. So, as I mentioned it on the previous videos, these sessions are being partnership with New Media Manitoba. And today is our third session, and it's our fourth session. So, why don't we get started? As always, I want to encourage you guys to go into my website and follow along the course. I will be uploading each of the sessions. I'm just one behind. I haven't finished it yet because I want to add a couple of more things from some of the suggestions that I got from you guys. So I will be adding a download link to get the assets that I'm using on this game so you can also play it along. But once I have it, as well as the video, the recording, because remember all of this has been recorded and is saved in the New Media Manitoba channel and as well in my YouTube channel. So if you want to go ahead there and check it out, and maybe if you missed one of the sessions, you can go back, catch it up, and join on the next one as well. I was wondering if someone was able to do what we covered on the last session, and if they were ambitious enough to go ahead and try making that jump that I asked for, to see which kind of like crazy ideas you came with or how to do it, because as I said on the last video, there are so many ways to do it. The one that I will present today is just one of them. It doesn't mean that it's the best one. There are way different ways, and of course, we could like dive into a way better mechanism on how to jump, but that's not the main point, right? We want to make just a 2D game right now that we can like even put into our phones or in a website and play it, because this is just the Unity basics. All right, so why don't we get started? So I want to show you guys where we left last time. So if you also want, you can pull the project from my GitHub. I made it public so you guys can pull the project and just check it out, like what we have done. I made some of the like a lot of commits for you guys to like know what was committed on each of them, and what was covered. And if you pull this project and also check the videos, you will be able to follow along as well. But I will recommend you to create your own project and start creating it. And remember, you can ping me even on GitHub to my account, and I will be able to help you if you get stuck at some point. But like that's the fun part, right? Okay, so if we go into our so another thing to mention is this is great for you guys, like that's another of the advantages of having a Git repository, even for your own sake. Like we left this the last week, but like I miss you so much, guys, that it feels like it has been quite a lot of time. So if you don't remember what we did on the last time we met, we were adding like all the animator controller for the player. We did some like sorting layers so like the assets will not like clip together. We created some prefabs, the player prefab. We started adding the player controller and the basic movement. If you remember, we were able to go to right and left. We added the colliders to the floating platform that we created. Like we created a prefab platform, the floating one and also the other one. So you can create a different type of level. And we started like playing with the rigid body and basically hooking up so the animation played when you move your character. So that's just looking at my commits. But if we go to our nice game here, we can see that we still have our three platforms on our player. Let's go on ahead and play so we can see where we left our nice project. Okay, so here is our player. If we go left and right, he will walk left and right. Cool. Right now, if I if I press up or W or even a space or whatever, it doesn't do anything because we haven't hooked it up to anything and it's not jumping. Okay, so the first thing that I want to do today is make our player to jump whenever we press either W or up. So for that, we are going to our edit project settings and we will go to input. Remember, we covered this a little bit, like pretty briefly last session. And we found out that there's like these axes that are already predefined by Unity that we can even edit. Like we can change the names or we can create new ones. But the cool thing is there are already some that are predefined, like the horizontal, which means whenever I press left or the alternative is A or right or D, I will be able to get that input into my code. Also, another important things to notice, compare. Hey, John, nice to see you here. So another very important things to notice here that we can compare between our first approach we did was just checking for whenever the user presses down the key on the keyboard, we will just get like a 1 or a 0, like either you press it or not. But with this axis, we get like how much was pressed, basically. So on the horizontal, if we print out, I think we did it on last time, if we print the value we get, we won't get like a straight 1 right away when we get the value, when we press the key. We will get it like incrementally going from 0 to 1, which is pretty awesome. Is great when we want to make it, for example, with acceleration. If we wanted our player to have some sort of acceleration, or for example, in this specific case, when we are going to use it for the vertical, which is pretty much, we're going to use it for the jump, even though there's a jump button, which is the space, but I don't want to use that one. The vertical for jump, we could use it to have like different heights of jump. So depending on how hard I press my key or for how long, my player will jump more or less, basically. So we know it's called vertical. That's the axis that we need to track, right? If we wanna go up and down. Of course, this is just one approach, but now the other key important thing that I'm gonna cover after I do the jump first, so you guys know why I need to do it, is I'm going to start just coding the jump. Okay, so this is our code. This is what we left, right? And we have here just a couple of functions. So in this area, we were creating the variables basically for the components that our player controller class will have. So far we have a rigid body and we have an animator. The rigid body, remember, this is the one that will let us do all the physics in our game. Like we will let Unity handle the physics of our player. And the animator is the one that is controlling the animations of our player. Then we have some variables. These variables let us like modify some of the attributes of the player. For example, the speed of how much, like how fast he walks. Then we have our start method. We already covered these methods in our previous session. Like there are some proprietary methods, the ones that are in blue, functions that are from Unity and are called like in a specific order. In this case, we're using the start method, which is one of the first ones that gets ever called, to initialize our component variables. We are basically just getting those components from our game object and assigning it to our variables. Then we use our update, which we split into two different functions, just so it was more clear and easier to read later. So right now we know we are updating our controls. Basically, it's just checking for the input on the control, and we are updating our animator. So whatever is related to the animator and we can control it in an update, it will be added here. And this last part is just so we can control like the rotation to flip basically our character whenever he goes to the right or to the left. All right. So I'm going to use, actually, now that I think a little bit more about it, and just so for you guys it's easier to check, in our project settings, the input, let's use the jump axis. So it's easier. We know we jump with the spacebar. It's pretty like straightforward. So let's go ahead and we will use that one. We are going to our code, and if you guess that this will be done in our update controls function, you were right, because that's what we need to do right now. So we are gonna track our jump here. So similar to this one, but in this case, we are not gonna care much into like how much is actually moving. We are just gonna make it right away. We just wanna jump whenever it's pressed. So we will say if input dot get axis, sorry, dot get axis, and we are gonna call our jump, right? If our jump variable returns something greater than 0, it means like it's going up, basically, like we are pressing the spacebar. We are going to call a function called jump, right? Because we just want to make it a little bit more clear. Maybe when you do jump, you want to do something extra. So why not? Why don't we just make it into a jump function? There are two ways to make it, and we just covered this last time. We can go ahead and create our function, jump, or we would have been able to let Visual Studio create the function for us, and we covered this in the last video. Okay, so in our jump function, we're gonna do something pretty similar to what we did into here when we were moving our character to the right or to the left. But as you notice here, we are setting the velocity to go up the same as the one that he already has, like our rigid body. So in this case, we want to do the opposite. So we can copy this and paste it here. And we will copy this piece and paste it here. We are going to change it for the x-axis. So in that way, we are going to keep our movement as it was from our speed movement, basically. And we're going to change this for our jump. So just so it's easier for us to manipulate our height, we are going to do float, and we are going to do jump force. Sorry, jump force. And we are going to assign that just right here, jump force. Okay, so if we do that, we should be able to jump. So let me just show you guys here. Let it compile our code. Remember, every time that little gear here down in the corner is moving is because it's just compiling our code. So we just need to let it do it. Okay, so now that that's done, if we go into our player, oh, sorry, I forgot to add a piece of code here. If we don't add this part, we won't be able to see that field in our inspector. So we won't be able to change our variable here. So let it compile, and we will see the variable pop up here when it refreshes. There you go. So let's go ahead and give it a value of 25, and we will hit play, and we will jump. So if I hit the space, our player is jumping. He just went so high. One of the reasons is maybe because it's too much of a force. So if I do 10, then that's better. But as you can notice, like something is wrong with our player, right? Like it doesn't feel like the player is actually moving right. So one way to kind of like hacky fix this is to change our gravity scale. So right now it's in 1. We can move it for 6, for example. Now our 10 is barely moving our player, basically. So I'm going to change it to 25 again, and that should be a decent jump. Okay, now if you just notice something, because we are not checking, like there's in our code, if we go back to our code, we are all the time just checking, did we press the jump? Yes. So it's gonna call this and it's gonna add the jump force. And it's gonna add it every single time that we press the spacebar. So I'm just gonna show you guys. If I go ahead again here and I press it and I press it, press it, my player is basically going to the sky because there's no checking when I can or cannot press. So if we think about it just by logic, what we want to do is to let our code or let Unity know that the user can only press the spacebar if our player is touching the ground, basically, right? Like he is, like his feet are in the ground. So one way to do that, so here we want to add that little thing. Oh, yeah. So we have a question here. So they are asking, what's the difference between public and serialized? Okay, so a public variable, so I could have made, instead of having this, I could have made public, right? And I go here and it will show, like it will still show here. But a public variable, like this is the access level this variable has. So from other scripts, whenever we start creating more scripts, we will be able to access that variable. But the jump force is not actually a variable that we want to share with other scripts. Like it's something just for our player. We don't need any other, like for example, the enemy controller or the checkpoints controller. Any of those scripts don't need to access our variable, right? So we wanted to keep it like private. This means it's private, like right now it's private. And the serialized field, what it means is just that Unity will be able to display it in our inspector. Of course, there's way more behind what is serialized file, but we can see here like force Unity to serialize a private field. So this is used for way more other things, especially when you are dealing with JSON files. And we're not gonna cover this data right here, but I'm just using it to force Unity and show it into our inspector, basically. Just because we wanna be able to change that variable in the inspector, but we don't want any other code to change it. So if I create here a quick example, I'm gonna create a test. I create test. You're welcome, but I'm gonna show you a quick example. I have tests here. I'm gonna create player controller player. So this is my variable. If I hit player and I do the dot, it's gonna show me all the like functions and things that this class has. If you see here quickly, there is no jump or speed variable. If I make my variables public, I will be able to say player dot speed, and it's now showing because it's a public variable, so I'm able to access it. if I change back this to private, this is gonna throw me an error saying that player controller speed is inaccessible due to the protection level. So that's why in this case, that variable, I don't need it to be public. Like, it doesn't make much sense for me to make it public, so that's why I just leave it as private. And that's basically the reason. I hope that was clear and it cleared the question. And thank you for the question. It's great to have some like questions in the channel, because sometimes, yeah, like I could go a little bit fast on some of these things, because when you do it like every single day, you get used to it. But I love that someone asked me for this kind of thing, so I can explain a little bit more those concepts. Okay, so if we go back into our code, I'm just gonna add here that we need check if the player is on the ground. I'm sorry, I put it in the wrong place. We want to check that before calling our function, right? So how do we check that our player is actually touching the ground? So there is a pretty nice way to check that in Unity. I'm gonna show you just one way. The same thing, like always, there is gonna be multiple ways to check. But the rigid body, and like physics in general, has a great tool for us to do it. So of course there's multiple ways. Like, one way that you can think of will be to just add a collider here, right, down from the player. And whenever that collider collides with this one, basically, it means that the player is touching the ground, right? But that's not too, like in terms of performance, it will be bad. There's way better to do it. And one of them is using an overlap of these like surfaces. So I'm gonna go into our code again, and we are gonna start actually messing around with physics. So remember in the previous class when I showed the diagram of like the different methods that Unity has, and there's one that is called void fixed update, and this method is pretty much used for all that is related with physics. So this method is very useful when talking about physics. So whenever we want to do something with physics, we want to use it here. Why? Because the fixed update, as the name says it, it's fixed. And that means that we won't have like delays in our physics or anything due to our frames per second of our computer. So that's pretty good. So we're gonna use a function. This is something from Unity as well, which is called physics 2D in this case, because we have a 2D game. And we're gonna call something that is called overlap. So we have here a different types of overlapping. So we have an overlap area, we have overlap box, we have overlap capsule, we have overlap circle, point, collider. There's like multiple ones. For this case, we can like pretty much the point probably will work. I found that it's sometimes not that accurate because it's too small. Like the area that covers and like it's checking is pretty short. The circle, the problems that it has is because it's a circle, right? It doesn't really represent our players' feet. So if you see, if I could have made a small circle here. So I'm gonna just show you quickly what I'm talking about. So if I go and say a circle collider, right, and I make it down here, you see that it's hard for me to kind of cover the area of the feet, like if I make it down here, it will work. Like every time that this little circle will like overlap these areas, it will tell me like, yeah, it's grounded. But the problem is, what if I go to the corner, like the player goes to the corner? When we are looking at it with like as the user, we see like the left or like the right feet, actually this feet is still touching the ground, but for our game is not. Like as soon as our player, like half of the body is away, it will count as our player is falling basically. So that's why I don't like the circle one. So the best one to use, and the one that I recommend, is doing a box collider, because we are able to just make a little box like here and check for that area. So basically, whenever we have at least 1 feet in the ground, we will be able to jump or like be grounded. So we are gonna use overlap box, and we are gonna start like talking about what does it require. So the first thing that it requires is which is the position where we want to track our our overlap. So we want to do it here. If we do it like just the player, it will be like somewhere here, so it's gonna be hard. So what I'm gonna do is just gonna create a child object, and this is our ground checker, right? And we are gonna place it right down here, and we can put it like in the middle of the player. That's about right, I think. Maybe then I will have to change it. It's just put it in there somewhere. We can add this little thing. This is just for you to know where an object is when it doesn't have like a visual, because as you know, like it's hard for me to tell where was it, but now I have this little dot that tells me where is my object. So I have it there, and I'm gonna create a quick variable here. So this is not a variable for the player to control, like this is not a variable that controls our player. This is just one, like these are other variables, and this one we wanted the same way. We wanted to be able to edit it on the inspector, but we don't really want it. It doesn't require to be a public variable, and we're gonna call it. We're gonna make it transform, because we only require the transform of that game object really, and we can call it ground check. So now that we have that, we can go back into our thing, and we are gonna say ground check dot position, and that's it. It's asking us for a vector 2 position. So since we are doing a physics 2D, it only like this only it's only looking for the x and y position basically, like in a Cartesian, in this Cartesian plan. We don't require the other axis, so it's not gonna grab it, because the position of course is gonna return a vector tree, but like Unity is able to just say, oh, you are giving me a vector tree, but I only need the two first variables, so there you go. It's just gonna cut it basically, which is pretty good. If we hit our comma here, it's gonna give us a hint of what is looking for. So another cool thing from Visual Studio is that he gives us some like nice previewer of what does the methods that OverlapBox has, and we can see here there's different ones. There are 6 different types of OverlapBox that receives different parameters. So in our case, we are not gonna use that one. We are gonna use this one. Yes, I believe so. Now, actually, yes, this one is the one that we require. So now it's asking us for the size. So how do we know the size? Like it will be a little bit hard to know what's the size right? Like just by doing it eyeballing, that will be pretty hard. So what we are gonna do is do again this here, and we will say vector 2. Let's say it ground check size, right? We're gonna make it like that. Yes, and we are going to use that ground checker size as our size. Then it's asking us for the radius, for the angle, sorry, here, and we can go ahead and say for now 0, I believe. If not, we will change it. And then it's asking us for a layer. So layers, I think we haven't covered those much, but they are here. Like we have talked about them a little bit. Basically, this is a very powerful thing from Unity that we will use a lot. It will let us define like different layers, and this, just so you know, these are different from our like our sorting layers. These layers are different. You can see there's already some that are predefined, but these layers we can define how they are, how do they behave and how do they interact between each other. If we go into our project settings here, and here we have our chart, like this little graph, it's amazing. And we can say, for example, the water layer doesn't interact with the UI or something like that, so we can turn off that check. So it's pretty good, and we can separate things. It's basically like separating our objects in different layers, depending on what type of object we have. So we want to create a new layer, so we just go add, and we are gonna call it ground, right? And we are going to go into our environment, like our platforms, and we only require the ones that has the box collider, really, to have our ground. It's gonna ask if we wanna apply this to all of the objects that are inside. We don't really need that, so we can just do it that way. And the same for the other one and the floating one. We wanna add ground, no, and there you go. We have all of our platforms as if they were ground. So they exist in the ground layer, and our player exists in the default player right now. We're going back here, and we wanna ask the user basically what we want to do is being able for us to select which layer we want to use. We could have just like straight ahead put it here, but it's nicer if we do it like this way. LayerMask, and we call it ground, and then we just put it here, so you guys can see how when we select layers it looks in an inspector. Okay, so I have this right here. Let's go into our player. Let's let it compile. It's compiling there. Now we have to assign our ground checker. It's asking us for the X and the Y value, and it's asking us for which of the layers we want to use. And I just selected ground. Sorry, ground. Okay, we have a problem here. It's gonna be pretty hard to determine like how big, how much the X and the Y size is gonna be, because unfortunately that overlap is not displayed here as a gizmo like the other ones we have. But there's a quick like trick that I'm gonna show you guys, which is pretty nice, and I wanna just show on how to show that little thing basically. And that's using another function from Unity, which is called on draw gizmos selected, right? And here we are gonna do gizmos dot color, so we can pick our color on how we want to color it. Color, and we can call red. So here you have seen that there's like two new things that I just used, and these ones are also some like Unity Engine functions that Unity give us already, and one is the gizmos that give us the ability, as it says, gizmos are used to give visual debugging or setup aids in the scene view. And then the color, which comes as well from Unity Engine, to represent an RGBA color. And there's already some predefined, and one of them is the red. I'm just using that one. Then what we want to do is say gizmos dot draw a cube. That's basically what, like, the closer thing to the box that we are creating. It's gonna ask us where is the center of that box, and we already know where we are creating it. So ground check dot position, right? And it's asking us for the size as well. So we are gonna say ground checker size. If we do this, now you will be able to see here once it loads, and that is gonna draw our little box. Right now it's not, you're not gonna see anything because it's 0 0. So let's go here and say 5 5. Of course that was too big, so let's do 1 and 1, still being too much, right? So if we want to say our, I believe, if I'm not wrong, it was like 1.8. That's briefly like what we wanted. And from height 0.1. Okay, that's a pretty nice box. So the height is perfect. Like whenever this is overlapping our ground here, and I made it basically the same size of our box collider, a little bit longer. We could even make it a little bit shorter. This might be too much. 0.7, yeah. I'm just making it a little bit longer. Yeah, like better like this, 7 something. Yeah, cool. I'm making it that way just because if we don't make it, it will happen something similar to our circle. And it's every time that we see that our player still has 1 feet there, and we want to jump, the player won't jump because he doesn't see that it's grounded. And it's pretty annoying. Like when you are walking and you want to go very to the edge, and when you jump, the character didn't jump and just falls. So it's pretty annoying. So this will fix it. So that's a pretty nice hacky way to do it, to like show it, and it's very common. Like as you see, the description of the gizmos is an aid to set up something in your scene. So it's pretty nice. Let's go back to our code. So now we have this, right? We are doing the overlap. What we can do now is that we can create just a variable. This one doesn't require to be serialized or anything, and it's gonna be just a bool grounded. Let's call it grounded, and we are gonna call it like that. And we can just assign it here, grounded. It's equal to this. So basically, what we are saying here is, if there's an overlap with these conditions, return true. If there's no overlap, this will be false. That way, it will be pretty easy for us here where we said we needed to check, just to say and, right, grounded. So whenever we are grounded, we are going to be able to jump. So let's go ahead and give it a try. So if we go into our play, let's let it compile. We have already set all of our variables, if I'm not wrong. So it will fall, and I'm gonna hit space. Oh, remember, oh, this is something good for you guys to remember. Every time that you change something in the inspector when it's on play mode, it won't take effect when you like on play. So our 6 here, when we change it, didn't take effect. Now if I play, I'm gonna hit space, and I'm hitting like multiple times the space, but I'm not able to jump just because my player is not grounded. I'm just gonna show you guys pretty quick so you can see how nice that looks. So let's add it here. On play, I'm gonna hit play, and here is our grounded. So you see, now it's grounded, now it's not grounded. Boom, boom. So it's pretty nice. All right, we don't need this. So that was jumping. Now we have our player is jumping and it's checking the ground. It's pretty good. Now we just need to add our little animation. So we already created a jump animation, right? Which is this one. There you go. Pretty nice. We just want to go into our animator, and what we want to do is to add a new variable, right? That is gonna be jump. Since the jump is just like an activity that happens once and then it should like kind of go back, we are going to make a new variable which is gonna be called, is gonna be a trigger. We already covered a trigger is just something that happens once and that's it, and we're gonna call it jump. We will make it jump from any state. It doesn't matter which state we are gonna be able to hit space and jump, because right now the only like parameters that we are checking is if it's grounded and we press the space bar basically. So every time that we hit a space, we're gonna use our jump and it will go to jump, right? So that way our player is kind of like always going to the right place. I'm gonna hit this, and then I'm gonna make a transition. I'm not gonna set anything right here right now. It's gonna look weird, but I'm just gonna leave it right that so we can check it out. Okay, so let's go back into our code, and we have to set here anim dot set trigger, and we just use the name of our variable jump. Just like that, we will tell our little player to do the animation whenever we hit the space bar basically. So you will see hip, the guy jumped, the guy is jumping. Now you might see there is something weird happening, right? So there you go, it's kind of jumping but it's looking weird. We need to be able to kind of like go back to our position before, like even before, because as you can see the animation triggers way before the thing happens. Okay, so to fix that, it's actually here on this transition. That's why I said I wanted to do it later. One way that we are gonna do is we don't want to do just has an exit time. We wanted to be able to cut it whenever something happens. So one of the ways to cut it is gonna be saying, okay, we don't have it here. We need to create some variables. But basically what we want to say is whenever the player is grounded again, we are going back to idle, right? So we are gonna add a new bool variable. It's gonna be called grounded. We already have that value. We can just assign it. And we are gonna say here, whenever it's grounded, it's gonna go into idle mode, right? That's easy. And then the other thing, I'm gonna add it just later, but let's give it a try to that. So we need in our update animator, we wanna say anim dot set bool grounded sorry, grounded and grounded. So we are basically just assigning the grounded variable that we are updating here on the fix update into our animator, right? So we have that there. So it's gonna change every time. And let's go ahead and test it out. Okay, so as you guys can see, there's something happening with our little player, right? Let me just check here quickly, jump. Okay, so it has loop time. We don't really need looping in our animation, right? Because like the jump is not it doesn't loop. That's one a way that we needed to fix. But also another problem that we are having is it's basically jumping twice, right? It's like it's going one and then twice. Okay, so we wanna fix that. But before, I am going to add, sorry, uh, another variable into our animator. So we wanna add a float value, which is gonna be called vertical speed. We're gonna track our vertical speed from on the code. That's basically here we will say anim.set float vertical speed, and that's our rb dot velocity dot y. So we are tracking our velocity, right? And what we want to do is we want to go into idle mode whenever our vertical velocity is also less than 0.1. And here we can add vertical velocity speed can only happens, or sorry, this we don't really need it here. We can go whenever grounded is true. That's a little bit redundant, but let's see if that fixes. That fixed it. So it just went, it just goes one time, but now it's going a little bit too much, and it's because, oh, I see what's happening. It's because our jump is, you see the trigger is being called. Yeah, that's because the jump axis. So this is one of the things that I was mentioning, because what we are doing here is adding a boolean, like we are just using the axis. And as I mentioned, I'm gonna show you quickly here. Debug. Actually, let's do it here. So it's not log jump is let's put it down here. Sorry, this was meant to be here. Plus this. Oops. Okay, so I just want to show you guys what the axis does. And if we go here, if I hit the space bar, it's gonna show me it's collapsed. It's going like it's doing it more than once. You see? Like even though I'm just pressing it once, it showed me multiple times, like there's more than one. That's something that we can change. Sorry, here. That was not the one that I wanted to open. Uh-huh. Okay, let me open that again. Let me check if there was something in the settings that we messed up. Jump. Oh, that looks about right. Yeah, so there's a way to fix it, but it will cause a little bit more trouble to us. So one quick way to do it is, so the problem is that the grounded is happening, like the grounded is not like checking exactly how we want it. That might be just because, oh yeah, I know what it is. So if we go to our player, yeah, like our grounded, it's going further than our box collider. So we want to just move this a little bit higher and even higher like that. Too much. That's too much. Yeah, something like that maybe should work fine. Let's check it out. Still happening twice. It's letting it pass twice, basically. Okay, so I'm going to give you guys a better solution for that one. Because for now it's happening twice. One way to quickly fix it is what I told you at the beginning. That's why I wanted to use it. So we just say get key down, key code space. This actually, no, let's leave it that way. We're gonna do something that I always like to do. um, so this is setting it to jump. We should be able to just fix it from here. Whenever this guy it's grounded, you should be able to go there. Let's just check it out again. That's This is still working. As you can see, the player is just jumping once. Cool. So our player is jumping. Good. Let's save our progress here. Okay. So we have covered quite a lot of things right now. We added basically all that is related with the ground checking and the jump. But basically it's the same thing. So I'm just gonna commit this and we want to add the jump animation changes and this one. Yeah. Yeah, the scene as well. So here is add jump function including animation and ground check. Perfect. Oh, I miss adding this one. This is pretty important. If we don't have that, it's not gonna work. So add ground layer. Perfect. We have that. We will push. And it's loading. That's good. All right. So we have our player that it's jumping and it's moving around. It's pretty good, right? I'm gonna add something else here in our animator. just to make it a little bit easier as well. But basically, we want to keep our idle also having some transitions. This might help us in the future. And every time our speed is gone less than 0.1, basically, plus whenever we are grounded, right? And also whenever our vertical speed is less than 0.1. Okay, let's hit play. That should keep working as intended. So we have our player there and it goes back to idle. Very nice. Okay, so we are having there a slight delay. Yeah, it's always going to that one. Let's leave it like that. That's something that will help us later. I just wanted to show you, but then we will apply it. Okay,